Hello students. So in this video we will be revising all the topics of friction chapter and all the topics are there in front of you. Let us start one by one. First we have static and kinetic friction. So in static and kinetic friction we will look at the variation of static friction and your magnitude of kinetic friction. Both of them we will see. Let us start. So static and kinetic friction. Now, to understand static and kinetic friction, first of all, what is static and kinetic friction? Static friction acts on a block, on a body when it is in rest. When it is in rest and the external force is trying to move it, but the block is in rest, then static friction acts. Kinetic friction acts on a block when there is some relative motion, when it is sliding, then kinetic friction acts, right? Let us understand their magnitude with the help of an example. So, let's say we consider a situation, a block of mass 2 kg is there, which is kept on a horizontal surface. The friction coefficient between block and horizontal surface is mu s 0.5 and mu k 0.4. Now we are considering a situation in which a block of mass 2 kg is kept on a horizontal rough surface and the friction coefficient is mu s is 0.5, mu k is 0.4. Now let us first understand your magnitude of static friction. Magnitude of static friction, right? So over here, considering that some force F is acting, initially this force is, let's say, 2 Newton. Initially force is 2 Newton. Will the block move? How do we decide? We will have to calculate the limiting friction value. What is limiting friction? Friction limiting is maximum value of static friction. Friction limiting is maximum value of static friction and it is given as mu s into n. Friction limiting, your maximum value of static friction, and it is given as your mu s into n, right? Friction limiting is also defined as the minimum, it is also equals to the minimum external force which should be applied for the block to move, for the body to move, your limiting friction. So in this case, what it is given, that force applied is your 2 Newton. Okay, how to decide whether the block will move or not? First of all, we will have to check your friction limiting value. Friction limiting value, how much it is? Mu s is 0.5 into normal. How much is your normal? Normal n upward, mg will be downward, which is 2g. So from this FBD in y direction, we can write n is equals to 2g, which is equals to 20 Newton. I'll substitute over here. So 0.5 into 20, that gives us 10 Newton. Friction limiting value is 10 Newton. That means this block will not move until a force of more than 10 Newton is applied on it. It will remain at rest only. Okay. So friction limiting is 10. We are applying a force of over here 2 Newton. How much will be the friction acting on it? Friction will be static and it will be equals to 2 Newton only. In this initial situation, static friction will act, static friction direction, because the tendency of motion is towards right. The force is acting towards right. So friction will have to act towards left to stop the block from moving. So static friction value will be, in this case, 2 Newton, we got it. Let's consider another situation. Let's say this F value is, if I consider, let's say it is 9 Newton. 9 Newton. Is 9 Newton more than limiting or less than? Your limiting friction is 10 Newton. Obviously, it is less. So, friction external is less than limiting friction. Then block will not move. Block will not move. And static friction over here will be 9 Newton only. Static friction will be 9 Newton only. Now, you notice one thing over here. How static friction is changing its value. According to the requirement, static friction will changing the value. Static friction, we say value ranges between 0 and limiting friction. Static friction value ranges between 0 and limiting friction, and therefore static friction is also termed as self-adjusting force. Self-adjusting force. This is static friction is also self-adjusting in nature, right? Okay. So again, coming back to our case. So friction static is 9 Newton when external force was 9 Newton. Now let's consider third situation. When force is 10 Newton, will the block move? No. Still your limiting friction is 10. So that means we need to apply more than that. So frictions will be equals to friction static will be 10 Newton. We say block is ready to move. The terminology or the sentence that is used is block is ready to move. The block will still remain in rest only right now. So till here, the block was in rest and your static friction was acting. Fine. Now, fourth condition. Let's say the external force applied is 12 Newton. External force applied is 12 Newton. Will the block move? How can we decide? What is our limiting friction value? Limiting friction value was 10 Newton. Your external force external, this is our force external whose value we are changing and checking. So, force external is greater than limiting friction. That implies block will slide. Block slides, block will move. And if block will slide, now static friction will not be there. Your kinetic friction will act. Which friction will act over here? Kinetic friction. Kinetic friction acts. Now static friction is gone. Your kinetic friction, once the block starts sliding, kinetic friction starts acting on it. So now your friction is your kinetic friction. This is your, sorry. So over here friction kinetic will come into picture. Next, so friction kinetic. How much will be friction kinetic? Friction kinetic is given as mu k into n. Friction kinetic is mu k into n. This is the relation for friction kinetic, mu k into n. How much is our mu k into n in this question? In this case, your mu k value was 0.4 and normal we calculated, that is your 20. What are we getting? 8 Newton. That means when the block will slide, it will be equals to 8 Newton. In this case, it is 8 Newton. Now you apply 14 Newton, you apply 15 Newton, you apply 20 Newton, you apply 30 Newton or 50 Newton, which is more than the limiting friction. All these values are more than the, once you apply more than limiting friction, the block will slide and friction will be kinetic, which will be constant. Static friction changes its value. Static friction is self-adjusting in nature. Static friction is self-adjusting in nature, but your kinetic friction is constant, right? Okay, so this is all we have discussed it about your magnitude of static friction and kinetic friction. This variation we can look also in terms of graph also. Let us draw it. One graph, if we see, let's say if on the y-axis we are taking your friction value and on the x-axis we are taking F external. When external force is 0, no friction is required. Block is in rest, no external force is applied, that means it will remain at rest. No friction is there. As external force increases, friction value also increases. External force was 2 Newton, static friction was 2 Newton. External force was 9 Newton, static friction was 9 Newton. External force, third over here it was, over here, external force was 10 Newton, your static friction was 10 Newton. That means there is a directly proportional and it is values are same. Up till which value? Till your F external is equals to friction limiting, you get, if I draw this is the graph we'll be getting. Angle will be how much? The angle will be 45 degrees. Why 45 degrees? Because whatever is the value of external force, same is the value of your friction also, till your friction limiting. In this part, when your external force was still limiting friction, the block is in rest. Block in rest, right? Block is in rest. After this, once your external force is more than your limiting friction, what will happen? Let us see. This thing, you can draw it. This is the situation. This is the situation. That means this is our kinetic friction value. This is our friction kinetic. This is our friction kinetic. As you will notice that over here in this range, the block is moving. It will be sliding. Block slides. And also you will observe that friction kinetic is constant. Once it starts acting, once it starts moving, it will be your kinetic friction will act and it will be constant. So this is the graph between friction and external force applied, right? I hope you understood it. Let us move next to our direction of friction. Let us look at it. Okay. So next we are looking at your direction of friction. Now I have drawn certain situations one by one and we will take a look at each one of them. So direction of friction. Many a time students have confusion regarding your direction of friction. First thing we should understand is that friction opposes relative motion. Friction doesn't oppose motion. Friction opposes relative motion. This is something that we need to understand. Friction opposes relative motion. Relative motion. We need to understand this. We need to get this point clear that friction opposes relative motion. Now let us take some examples and understand the direction of friction. Let's say in this first case what we have, two blocks are there, A and B placed on top of one another. That means A is placed on B. Now let's say a force F is acting over here. Due to this force, both the blocks are moving together. The situation that is given to us is that over here force is acting and force is acting in such a way that your both the blocks are moving together with same acceleration. They are moving together with same acceleration and same velocity. Together they are moving, right? So what will be the direction of friction? Now as you can see that this B block is moving forward towards right with respect to ground. So where will be the friction? Friction will be on left side on B. Next, if you will notice, between A and B also friction is there. All surfaces are rough. So between A and B, as we can see that no external force is acting on A. And if it is moving along with B with same acceleration and same velocity, that implies that friction must be acting. If you notice over here, what is the relative velocity? If both of them, this one also has V speed, this also has V speed. So relative velocity between A and B will be 0. If relative velocity is 0, that means A is in rest with respect to B. What type of friction will act between A and B? It will be static friction. Between A and B, static friction will act. And because the system is moving ahead and no force is external force, no external force is acting on A, that implies your static friction will act in the forward direction on A. So over here, static friction will act, whatever its magnitude, that something we'll see in block on block problem, right? In that block on block topic. But static friction forward on A, and because on A forward static friction is acting, on B it will be your in backward direction, right? So this is when the blocks are moving together. Let's consider another situation, second situation. In this case, let's say that block B moves with a speed of 2 meter per second and block A has a speed of 4 meter per second. Both are sliding against each other. Let's look at it. What is your velocity of B with respect to ground? Velocity of B with respect to ground, it will be 2. That means friction on block B will be in backward direction by the ground, right? This is over here. Next, if we see what is velocity of A with respect to B, velocity of A with respect to B, 4 minus 2, 2 meter per second. That means velocity of A with respect to B is 2 in forward direction. That means with respect to B, A is moving ahead. So friction on it will be in backward direction, and this will be kinetic friction because there is a sliding. Between them there is a relative motion is there. That means your kinetic friction will act. And because B is applying kinetic friction in backward, A will apply on B in forward direction. Okay? These are action reaction pairs. These are action reaction pair. Okay. Let's look at next situation. Third situation, I am changing the velocity. That means this is moving with 4 meter per second, B is moving with 4 and A is moving with 2 meter per second. First, in which direction is the ground applying friction on your B block? Obviously, B is moving forward, that means towards right with a speed of 4 meter per second. So, ground will apply towards left. Velocity of B is towards right, so friction kinetic will act towards left. Opposes relative motion. Your kinetic friction always acts opposite to the velocity. Fine. Between A and B, what is our velocity of A with respect to B? Velocity of A with respect to B. Velocity of A 2, velocity of B 4. Minus 2. A is moving, velocity of A with respect to B is minus 2. That means with respect to B it is moving backward. That implies your friction will be over here. This will be Fk1. I am terming it as Fk1 between A and B. And because on A friction is backward, the reaction we can say will be on B, it will be Fk1 in forward direction. Right? So with these examples, I hope we get clarity about direction of friction. Let us move ahead, look at our third topic, which is pushing and pulling. We all know that when we compare pushing and pulling, pulling is relatively easier compared to pushing. What is the reason? Let us take a look at it. Okay, Next, if we take a look at pushing and pulling, which is easier to do, pushing or pulling? So simple answer is pulling is easier. Pulling is easier. If I have to just answer it, pulling is easier as compared to pushing. What is the reasoning behind it? Let us take a look. So we have considered situation in which block of mass m is kept on a horizontal surface having friction coefficient mu s. The difference over here in the two situations is, in first case a force F is acting at an angle theta which is pushing the block, whereas over here force F is acting at an angle theta which is pulling the block. Now first of all, let us resolve our forces, the external force which is acting. So if we see over here F cos theta and here vertically F sin theta downward. In this case F cos theta and vertically up F sin theta. In both the cases, F cos theta is trying to move the block horizontally. In both the cases, F cos theta is trying to move the block horizontally, right? So which one will be easier to move? In which the limiting friction will be less. In whichever case limiting friction will be less, in that will be easier to move. Let us check our value of limiting friction. Friction limiting is mu s into n, normal, mu s into n. Normal, what is our normal? For this case, if we see, if we draw FBT, normal upward, mg downward. Let us, in y direction, let us balance our forces. So what equation I can write it? Normal is equals to mg plus f sin theta. So our limiting friction can be written as mu s into n, mg plus f sin theta. This is our limiting friction value coming in the pushing case. Let us look at it in our pulling case, what is happening. So normal will be upward, mg will be downward. Friction limiting mu s n, friction limiting mu s n, normal value. What is our normal value? Normal, if we again balance forces in y direction, we can write down n plus f sin theta is equals to mg. So our n value comes out mg minus f sin theta. Mg minus f sin theta is our normal value coming. So mu s into mg minus f sin theta, right? This is our friction limiting in case of pulling, and this is in case of pushing. As you can very clearly see that in case of pulling, because normal is less, your limiting friction is less, and therefore it is easier to pull a body as compared to push a body. In pushing, your limiting friction value will be more, right? Let us move ahead. Okay, so we have done about your pushing and pulling. Now we are talking about your minimum force required. So pulling is easier as compared to pushing, but in pulling also, how much force? What we mean is that let's suppose a condition is given to a situation in which a block of mass m and a force F is pulling the block, right? Force F is pulling the block at an angle theta. How much minimum force is required to move, and what is the angle theta? At what angle should we apply this force F? So let us see how to find out this. Over here, this will be F cos theta, right? F sin theta, normal up, mg down. F cos theta is trying to move it, and friction static is opposing it. So friction over here, F cos theta is trying to move it. When will the block move? Block slides, or we can say block starts sliding when your F cos theta will be equals to friction limiting. How much is our friction limiting? Friction limiting is mu into n. I am taking over here mu n. Whenever, if mu s or mu k is not mentioned to you, one point I am just moving a little away from this topic, and I am mentioning over here, if mu s and mu k are not mentioned and only mu is given to you, then please take it as your mu s and mu k same only. And if mu s and mu k are not separately mentioned, then take it, whatever mu is given, that is what we will consider as static, and that is what we will consider as kinetic also. Fine. Again, coming back. So where we were. So block is F cos theta is trying to move it. F cos theta is trying to move it. So block will start sliding when F cos theta will be equals to your limiting friction. Limiting friction is mu into n. How much is our normal value? In the previous case we have calculated. Again we'll write it. So F cos theta is equals to mu into n. N over here, if you see, it is mg minus f sin theta. By solving this, your f value will come out to be mu mg by cos theta plus mu sin theta. This will be our force, right? This is the force which is required. Now we want a minimum force. How much is the minimum force to move the block? So for force to be minimum, this cos theta plus mu sin theta value should be maximum. Cos theta plus mu sin theta maximum. How do we find out cos theta plus mu sin theta maximum? We will use the concept of maxima and minima over here. So d by d theta of cos theta plus mu sin theta, when we put equals to 0, our theta value will come out to be tan inverse of mu. That means tan theta will be mu. Tan theta is equals to mu, right? Now tan theta we have got mu. That means at what angle the force should be applied? It should be equals to theta equals to tan inverse of mu. Next, we want to find out minimum force. So if we want to find minimum force, we can substitute. Once we have got tan theta value as mu, tan theta value we have got as mu, so we can substitute cos theta and sin theta value. What is our cos theta sin theta value? Cos theta can be written as, if this is our tan theta, mu 1. So cos theta will be 1 by root over mu square plus 1. Sin theta can be written as mu by root over mu square plus 1. When we substitute sin theta and cos theta in this, our force comes out to be mu mg by root over mu square plus 1. Right? So this is our answer. The two results that we should keep in mind over here, theta, and this is our minimum force. This is our minimum force, force minimum. At what angle should the force be applied? At what angle your theta equals to tan inverse of mu? How much force should be applied? Mu mg by root over mu square plus 1 for the minimum force to move the block. This is the minimum force, and at this angle this force should be applied. I hope this is okay. Let's move ahead. Yeah. Next we are talking about your contact force. So contact force, generally students keep this misconception in mind that contact is your normal force. It is not completely true. Normal is a component of contact force. Normal is a component of contact force. What I mean is, the two forces applied by the ground or surfaces, one is your perpendicular, which is normal, and then tangential, which is your friction. So force contact force is resultant of normal and friction. If we see over here, if we draw the parallelogram, so this is normal, this is friction, the resultant is coming, this is your contact force. Contact force is resultant of normal and friction. So if we write it, root over normal square plus friction square. Now we know that friction value varies between 0 and mu n. Friction value varies between 0 and mu n. So we can write down force contact will be root over n square plus 0, that is your n, and maximum it can go to, friction contact will be root over n square plus friction we know is mu into n. So friction, it will be your mu n whole square. So over here we will get it, friction contact is n coming out 1 plus mu square. What is the range of your contact force? Contact force, it can be greater than or equal to 0 or less than or equals to n times root over 1 plus mu square, right? The point is basically, first of all, you should understand that contact force is resultant of normal and friction. And now this should be clear in our head that it is resultant of normal and friction. Then we can solve it according to the given situation. Fine. Let's move ahead. Next, we are looking at angle of repose. Angle of repose is related to your inclined plane. Let us see. So, next, angle of repose. First of all, what is angle of repose? If we have to define it, it is angle of inclination when block starts sliding. When block starts sliding, right? Angle of repose is that angle of inclination when the block will start sliding. So the situation we have is a inclined plane having inclination angle theta. A block of mass m is kept on the incline, friction coefficient is mu, right? Over here, which force is trying to move the block? We know the component of mg, which is mg sin theta is trying to move it. Friction will be trying to stop the block from the motion. That means friction will be acting in opposite direction, right? Other forces which are involved are normal, perpendicular, and your mg cos theta, which is perpendicular. Now, if let's consider friction limiting value. So mg sin theta is trying to move the block down. Friction limiting value over here will be mu into n, and n value in this case is mg cos theta. So mu mg cos theta, mu mg cos theta. If we talk about the motion will happen when mg sine theta becomes equals to mu mg cos theta, because this is your force which is trying to move the block. This is the limiting friction which is trying to stop the block, right? So mg sine theta will become equals to limiting friction, your block will start sliding. Now in this, if we solve it, mg cancel out, sine theta by cos theta, tan theta is equals to mu. That implies theta is equals to tan inverse of mu. This is our angle of repose, theta r. You can also mention it as theta r. That means at tan inverse of mu, when your angle of inclination is tan inverse of mu, the block will slide. The block will start sliding. We can also mention that if theta is less than theta r, that means if angle of inclination is less than your angle of repose, this will happen when mg sine theta is less than mu mg cos theta. 1 minute, I'll write here. So this thing will happen when mg sine theta is less than mu mg cos theta. In this case, block at rest. Block at rest. Next, if we say if angle of inclination is greater than your theta r, that is angle of repose, this will happen when your mg sine theta will be greater than mu mg cos theta, right? In this case, your block slides. In this case, block slides. And when the block will be sliding, your acceleration, how much will be acceleration? Acceleration will be g sine theta minus mu g cos theta. G sine theta minus mu g cos theta. Acceleration, how we got it? Net force by mass. Net force downward will be mg sine theta minus mu mg cos theta. So from that we get acceleration. This can further be written as g of sine theta minus mu cos theta, right? So from this topic, what all we have to consider, the results that we have to remember. This is your angle of repose. Angle of repose tan theta is equals to mu. Second thing, when the block will start sliding, when the block starts sliding, the acceleration of the block on a rough surface is, rough inclined plane is this g of sine theta minus mu cos theta, right? Okay. Okay. So we have block on block. A situation we have taken, two blocks having mass m1 and m2 and friction coefficient is mu1 and mu2 and a force F is acting on the lower block m1. Will the system of blocks move? It depends on the value of force F and the friction, that is your limiting friction applied by your ground on m1. When block m1, that means the force acting on block m1, F will be greater than friction 1 limiting, the system will move. We can say system moves. This much is minimum force required. How much minimum force required? The limiting force, the limiting friction applied by ground on m1. How much is that? So force must be greater than mu1 into n. Normal over here, normal by ground on m1. How much it will be? Mu1 into m1 plus m2 into g. Okay. So at this values of 4, for forces more than mu1, m1 plus m2 g, the system will be moving. Next, what will happen? Once the system starts moving, for initial values of force, your m1 and m2 will be moving together. They will move with same acceleration. And gradually, when we increase the value of force, a situation will arise at a value of force F, a sliding will start between them. A sliding will start between your m1 and m2. Now, when sliding will start, so to find out the value of force, I can call it F max. That is the maximum force till which both of them move together. After that, they start sliding. So to find out this F max value, this is F max is when sliding starts. Sliding between m1 and m2 starts. Sliding starts between m1 and m2. To find out your F max value, we need to understand what is happening between m1 and m2. Which force is helping m2 to move ahead along with m1? It is on this m1, your downward from ground, F1 will be acting over here. Which force is helping your m2 to move together? Because they will be, when they are moving together, there will be relative motion will not be there. So static friction will act, and static friction F2 will act in forward direction on m2, and on m1 it will be in backward direction, right? Now F2 is not unlimited. There is a limit to your F2 value. How much is your limiting friction for F2? If we calculate, F2 limiting is mu2 into n between your m1 and m2, which is equals to mu2 into m2g. Now force between m1 and m2 can be maximum this much only. So acceleration maximum of your m2 will be, acceleration maximum will be friction to limiting divided by your m2. How much are we getting it? Mu2 into g. That means for this value of acceleration, till this value of acceleration, both of them will move together. Can we calculate maximum force using this acceleration? Find out. Let us see. So considering both of them as a part of a system, because they will be moving together with same acceleration. So we can write down F max minus this force is externally, friction is from the ground on the system. So F max minus F1 is equals to m1 plus m2 into acceleration. Acceleration is mu2g. So with this equation, we can calculate the force at which sliding begins between m1 and m2. For forces more than this, sliding will begin. And to calculate individual acceleration, the maximum acceleration for m2 will be this much only, right? To calculate acceleration further for values more than f max, we will have to apply f net equals to ma on individually on your m1, right? So I'll summarize all this, what I just discussed over here. Two block system is given to you, m1 and m2. First of all, will the system move or it will not move? System will move when this F over here, the force which is applied over here on the lower block, is more than the limiting friction provided by the ground. Limiting friction provided by ground is mu1 into m1 plus m2g. m1 plus m2g is the normal over here. Okay, so if let's suppose that this force is greater than this limiting friction, the system moves. System will move up to a certain value of F, the system will move together. Why? Because the friction between m1 and m2 is sufficient to support the acceleration together, what combined acceleration. But after some time, when the force value increase, they will start sliding. And to calculate at what force your sliding will begin, what is our maximum value of friction which is available for m2? Maximum value of friction available for m2 is mu2 into n, that is mu2 m2g. So what is maximum acceleration of m2? Maximum acceleration will be mu2 into g. So the combined maximum acceleration can be this much only. Now for this whole system, we are applying F net equals to ma. On whole system, external force is F max. Over here, F max minus F1 is equals to total mass m1 plus m2 into acceleration, which is your mu2g. So with this equation, we can calculate the force value at which the sliding will begin, right? Okay, let us move ahead. The last topic we'll see is your friction on chain. So the situation we have is, we have a chain of mass m and total length L, which is hanging on a table, a part of this chain is hanging on a table, right? Now the questions that are framed in this is something that how much length of the chain can be hanged such that the chain does not slide, or another, at what value, at what length the chain will start sliding. So let us consider, let's say that over here the hanging part is x, and over here on the table, then how much it will be? L minus x. Now basically what is happening, you consider, it is kind of, you consider in your mind, two blocks are there. One block is over here which is hanging, right? And another block which is kept on the horizontal table. It is kind of like that. If you imagine that way, it is easy to understand it. So we have this part of the chain, x length part of the chain, which is hanging and which is trying to pull the chain down. And you have L minus x length of the chain, which is on the table and on which your friction will be acting. And it will try to stop the chain from sliding down. So the situation is, this part is trying to pull the chain down and this part is trying to stop. That means the friction acting on this part is trying to stop the chain from sliding. Let us see. So ultimately it is the force which is acting on this part. How much is the force acting? So beta, L length is having total mass m. So unit length will have m by L. So x length of chain will have how much mass? X length will have mass m by L into x. This is the mass of this much part. Mass of x part is m by L into x. What is the mass of L minus x? So we can write down L minus x will be having m by L into L minus x. This is the mass of m by L into L minus x. Simple story now. We have got the mass of this hanging part and the mass of the part which is on the table. What is the force, the gravitational force acting on this part? We can write it as mx into g, when will become equals to the limiting friction acting on this much. Friction limiting acting on L minus x part, the chain will start sliding. So mxg is, we calculated m by lx into g is equals to friction limiting on this much part, mu into normal. How much is normal? Normal over here will be equals to m into g. Mass of this, how much is mass of this? M by L into L minus X into G. So this is mu into N, and N will be, N was equals to your mg of this part. If we solve it, M by L cancel, G cancel out. So your X is equals to mu L minus mu X. Further, when we simplify it, X value comes out to be mu L by 1 plus mu. That means this is the part of the chain, this is the length of the chain till which your chain will hang. After that, till this length it will be hanging, after that it will start sliding. Okay, fine. Please keep this result in mind and how we have got it. I hope this part is clear. With this, we have completed all the topics of our friction chapter. I hope you found the video helpful, and other videos are also there for other important chapters. We have made revision videos. Do check them out, right? If you find it helpful, do consider to press the like button and subscribe to our channel. Thank you very much. Bye bye.